So setup, obviously we're attaching the support rods, and here's the little tricky part is you are going to need a couple components along one of the rods right here. So first thing first, I'm going to take my short connector rod and I'm going to go ahead and insert that into one end and tie that down. And I'm not trying to be too crazy about the precise location of these things, but we'll adjust it as we go along. The next little component, you will use a Durlin block, and so the Durlin block, similar to the rod connectors, it will connect as such. I will take my threaded rod connector and I will go ahead and attach my 3-step pulley to this. Now the 3-step pulley can move freely on the rod unless I tighten it down with my Allen wrench. So I'll just give that a nice little tight fitting right there. Now remember, don't tighten it too tight. You know, you'll damage equipment, so on and so forth. So that rod connector is going to connect in just like that. Moving on right here, we are going to need to replace one of these bolts with our hook bolt, and this will be connected to our bottom piece. All right, so there we go. Now at this moment, what I would do is go ahead and add some support right here with my last support rod. I just make it a little more sturdy. So we're gonna be pulling some weights around, and so I'm gonna use this. Come on. All right. It's a little tricky sometimes. You gotta be very patient. I'm not being too patient right now. But anyhow, here we go. All right, so that's a basic setup right there. Essentially, what I'm going to do is take another hook bolt. So we're using all 5 rod connectors here. I'm going to take another hook bolt. Remember, take this bolt and throw it back in your box so it doesn't get lost. Want to make sure future students have the same opportunity you're having to use this beautiful equipment. And so now I'll attach it onto. And so one thing you notice is it can spin freely with the Durlin block. You know, little things here and there is I would make sure that what we're going to do is we're going to take our scale and hang it from one of the S-bolts, and we will hang a mast to this end. And when I hang this mast, I want to make sure I give myself plenty of room for this mast to make that pulley work and spin. So I'm doing a real messy knot right here. It's not very good, but I'm trying to make this video as short as possible without giving away too much information, so that you can kind of have some fun on your own right here. But it doesn't look like that knot's going to work very well. I'm going to try it one more time. All right. So that's our basic setup right here. Now, the one adjustment I would make is really the height between your pulley and essentially your scale right here. So what I'm going to do is I'm going to spin this around so you can get a good look at it. And I am going to, like I said, make some adjustments here. One thing I would want to make sure is we're aligned, that the scale is directly below the other hook bolt. that the hook bolt is nice and tight onto my my connector rod. There's plenty of room right there. Now, one thing I am going to do here is I'm going to go in and use some nylon cord so that I can ensure that my S-bolt, my hook bolt, doesn't move all that much. So what I'm going to do here is connect some cord from this hook onto that hook, and that'll take me a little bit. So why don't we cut right there, and I'll just show the final setup. All right, so this should be your final setup. I added in our cord that connected the bottom of our scale to our hook bolt. One thing you want to make sure is that your hook bolts are both parallel to each other, and then that this top hook bolt is perpendicular to your spring scale, so it should form a 90-degree angle right there. One thing to talk about before you even attach the spring scale on there is we are going to have to find the weight of this spring scale. So one thing I'll talk to you about is that these scales are able to be zeroed by this little lever, this little section you can pull back and forth. So what you want to do is hang this if it feels hanging freely, and make sure that you zero that out by pushing that little scale to 0 point. So once you have that zeroed out, real simple, you just take this and flip it over to the other side, and you can get a force reading off of that. And this should be done before you even complete the setup, essentially so that you can attach the spring scale on there and you don't have to unattach it later. But this is going on data table number 2, the first little section, the weight of the spring scale. And we have that, that's going to be in newtons, and that's the way you would find that. All right, moving on. We're trying to fill out data table 1 by taking a couple measurements. The first measurement you're going to take is the circumference of your 3-step pulley. An easy way to find the circumference of something is, other than pi r squared, is what I could do is use some kind of material like a string that I have here, wrap it around my pulley, and mark the end part. Mark 1 complete revolution around my pulley. Then I will take that over, and ideally you probably want to make a mark with a marker, and then I can get a reading in centimeters for my circumference. So that would be how you would fill out the circumference section in your data table number 1. We can take centimeters and convert that over to meters. We can also use that, the value of our circumference, to find the radius of our wheel. And if you notice, it will have to be in meters. In addition to that, we are going to take the total mass that we're using, which is going to be 750 grams. So here's 500, 200, and do not forget that the hook, the weight holder, this hook little piece is 50 grams itself. So you're looking at 750 grams. You would convert that over to kilograms. And then we're taking a couple force readings. The force that's of the hanging mass, hopefully you remember, essentially is Newton's second law. The force of weight, the force of gravity on any kind of mass is the mass times gravity, m times g. So we got 750 grams, which is 0.75 kilograms, times 9.8 meters per second squared. Should be right around 7.5 if you're rounding your 9.8 to 10. And then in addition to that, we are going to find a value for our torque. Something we've talked about in class is that torque is actually equal to force times the radius. Okay. All right, so on to data table number 2. We did take the weight of the scale. As I showed you earlier, we zeroed it out, and then we just flipped and held the other side, and I could take a reading in newtons for that. So that's going on our data table under the weight of the spring scale. We will take a reading on the spring scale, which you could take a reading of that spring scale. And so essentially what that is, you know, I know that the force that's pulling down on the spring scale or providing the total force is going to be the sum of these two, the weight of the spring scale along with the reading of our 750 grams hanging on the other side. So those two together will give you a total force. The length of the lever arm. Now the one lever arm that's involved right here involves our hook bolt. And so the length of this lever arm I could find by taking my ruler and measuring from the center of this connecting rod. So I place my 0 right there, and I'm gonna try to get as close as I possibly can to that little section where my spring scale is hanging on. So if you're looking pretty close in right here, it's right around 6.5 centimeters for me. I would take those 6.5 centimeters and convert that over to meters, and then again it's going to lead me into the ability to calculate torque, which again would be force, our total force in this situation, times our lever arm in meters, and that would give us our torque. Thank you for joining us for, I should have cut that. All right, so on to data table number 3. So a couple things you want to take some measurements of before you even start the lab is there's a section on data table number 3 that is asking for an initial height of your weight right here. So one thing I like to do is set my weight hanger on top of the breadboard, and then as I tie my knots, I want to make sure that I got a nice tight taut nylon cord right here. So you know what I would take that as is my height's going to be initially a 0 height, so I can fill that in on my data table. We will go ahead and as you work through the procedures, it's going to ask you to take this and make 2 complete revolutions, and then reconnect your scale hanger on here. And so, you know, every other reading you're going to need, whether it's going to be, you know, a final height, you can do that. It's going to be in centimeters. You would take the final height. So we know that we started at 0, we got to 15, so then there's, or whatever it may be. And then so you can fill in essentially the distance, the weight was moved in centimeters. You can figure that out by finding the difference between the final and initial height. There's just another couple readings you could take, which is off the spring scale, and that can be found in the reading as you read along your directions. But essentially, here's the setup. There might be a couple questions about your angles and things like that. But you know, if you're running a nice and concise and pretty and really well organized experiment right here, you should not have many problems following along. It's really going to lead you into some great discussion questions at the end about torque and force and how forces can act in angles, forces can act in all directions, and you know, you should know some of this information from all the work we've done on mechanical systems.